Today's lesson is finding the area between two curves. Basically, I'm going to draw you a picture first before we read all those words. So, I have one curve goes like this, one curve goes like this, and I want this area. And we integrate from this point, which is A, and this point, which is B. What I want you to do is think back to good old geometry class when they gave you a problem and told you that this was a square and there's a circle inside it, and they want you to find the area of this. Okay, so what did you do? You found the area of the square and you subtracted the circle. So what we're going to do basically is the area under the blue curve from here to here is this. It's the whole thing. The area underneath the green curve is really this. So I'm going to take the blue minus the green, and I'm left with the purple. Okay? So here's the word. It says the idea of a definite integral finding the area of a region under a curve is related to the area of a region between two curves. Two functions are both continuous on the interval a to b. Then the regions between the curves can be found by subtracting the area of the upper region from the area of the lower region. Upper first, lower. Okay? We can rewrite this as a to b of f of x dx minus a to b of g of x, but you don't need to separate them. It's just kind of silly. You're just subtracting your functions. But the important thing here, if it's with respect to the x-axis, which is the picture I drew, you'd always top minus bottom. Always top minus bottom. If you got the equation with respect to y, which is page 2, you always do right minus left. Okay? Just get in the habit. Top minus bottom, right minus left. This is the top curve minus the bottom curve. Otherwise, you get the wrong answers. Okay, so let's think about it. Find the area of a region between two curves. 6 minus x squared and y equals x. Well, let's come up here, draw a picture. If you graph this, you're up here at 6. You got your curve. And then you got this line. So the area that we're interested in is this. The top curve is this one, and that's the bottom curve. We need these intersection points. Okay? Those give you the A's and the B's. So I can integrate. So first thing you got to do is set the two equations equal to each other. So you find out the intersections. I'm going to move this over so I get x squared plus x minus 6, which factors, of course, is x minus 2 and x plus 3. So I've got x equals 2 and x equals negative 3. Those are the bounds. So I'm going to integrate from negative 3 to 2. The equation on top is this one, 6 minus x squared, minus the equation on the bottom. You can simplify, get rid of your parentheses before you integrate if you want, but there's really no reason to. We can just erase them right now. So the integration ends up being 6x minus x cubed over 3 minus x squared over 2, and I'm going to integrate from 2 to negative 3, and you plug them all in, and your answer ends up being 125 over 6. 125, what I said, not what I wrote, 125 over 6. I am not going to spend the time doing the algebra in this video. You can do that yourself. But practice, because you won't have a calculator in your hand. You got to know how to do these without a calculator. Okay? Finding the area between two curves. Same problem. Only this time it's up here at 2. Here's my line. Here's that. I need the intersection. So 2 minus x squared equals x. Set it equal to 0. You get x squared plus x minus 2. X minus 1 and x plus 2. So x equals 1 and x equals negative 2. Those are your bounds for integration. Negative 2 to 1. Top equation is 2 minus x squared minus the bottom. So again, you get 2x minus x cubed over 3 minus x squared over 2 from 1 to negative 2. You do the magic math and you end up with 9/2. Okay? Not hard. Fun stuff. This one gives you a little bit of a challenge because you've got to figure out which equation's on top and which one's on the bottom. Okay? This is a parabola. If I plug in 0, it's crossing at 1, right? If I plug in 1, what happens if I plug in -1? You get 1 minus 2 is -1 plus 1 is 0. Good. So I've got a parabola doing this. Is that right? Probably not. Yes, probably is. And then I have a line, 2x plus 5. Slope has to be 2. So I'm doing this. So this is the one on top. This is the bottom. I have to find my intersection. 2x plus 5 equals x squared plus 2x plus 1. So 0 is equal to x squared. The 2x's go away. You get -4. So x is equal to plus or minus 2. Integrate -2 to 2. The equation on top is this one. 2x plus 5 minus x squared plus 2x plus 1. This one I simplified. So you get 2x minus 2x goes away. 5 minus 1 is 4 minus x squared. Is that true? Oh, and it's negative x squared. And you get 5 minus 1 is 4. Okay. Dx. So what? You get 4x minus x cubed over 3 from -2 to 2. And the answer is -32 over 3, obviously. Pretty good at my algebra, huh? Okay, so those aren't too bad. You have to figure out what they are. All right, now they get a little tricky because we're going to integrate horizontally with respect to y. So it's always going to be right minus left. Find the areas between the two curves. Remember, this is a parabola that's opening to the left because it's got a -y squared. And it's shifted over 3. Okay, so it's here. This is a line like this. So the right, this is right. This is left. Okay. So, first I set them equal to each other. Y squared equals y plus 1. Set it equal to 0, you get y squared plus y minus 2. Y minus 1, no, yes, minus 1, y plus 2. So y equals 1 and y equals -2. So what happens when you integrate, you're integrating this side minus that side from this point to that. So you're integrating along the y-axis instead of along the x-axis. It's nice to know you can do that because you don't have to necessarily solve for y, make it a y equals. All right? So I integrate from -2 to 1. Right minus left, so it's 3 minus y squared minus y plus 1. And when you get done with that, you should have 9/2. Okay? This is the same problem. Let's set it up. It goes like this. This goes here at 5. Okay, so this is 5. This is 9. We need to these intersections here, you set them equal to each other. So 4 equals y squared, so y is equal to plus or minus 2. Integrate from -2 to 2. Right minus left. And your answer should be 80 over 3. Okay, do the math. Oh, this is a good one. Find the area between two regions. These are both y equals, so you integrate with respect to x. See, the cosine graph starts at the top and goes down, right? Y equals 1/2 is here. So I'm looking for that region right there. Where do they intersect? The cosine of x equals 1/2. Must be pi over 3. Good enough. All right, so from 0 to pi over 3, cosine's on top, y is 1/2 is on the bottom. The derivative of the cosine is, the integration of cosine is sine. This is 1/2 x from 0 to pi over 3. So you get the sine of pi over 3, which is root 3 over 2, minus pi over 6. And you plug in 0, you get 0 and 0, so that's okay. Common denominators, you multiply by 3, so I get 3 root 3 minus pi over 6, and call it a day. Okay, find the area between two curves. This time they're x equals. You could solve for y, but then you have to deal with a plus or minus square root there. So let's leave it in terms of y. What does the graph look like? A y squared. It opens right. It must go this way. And this intersects when y is 0, x is 2. And we got a slope of -1, so it's going that way. So when you integrate your right minus left, this is right, that's left. But first we got to find out the intersection. So let's do that first. So you set y squared equals 2 minus y. Y squared plus y minus 2 equals 0. Y minus 1, y plus 2. So you get y equals 1, y equals -2. So -2 to 1. The one on the right, which is 2 minus y, minus the one on the left, dy. So what do you get? You get 2y minus y squared over 2 minus y cubed over 3 from -2 to 1. You put it in, do the math, and you get 27 over 6. Not bad. Okay, last one. The area of the region in the first quadrant enclosed by, so that's y equals x minus x squared, and the x-axis. So it's a parabola that opens down. Okay, and where's it go? It's 0 and 1, 0 and 1. So that's what we're looking for. So my integration's from 0 to 1. X minus x squared dx, which is x squared over 2 minus x cubed over 1 from 0 to 1. So you get 1/2 minus 1. Oh, that should be over 3 minus 1/3. So in terms of 6, that's 3/6 minus 2/6, which is 1/6. Yay! We're done. That's all there is to it. Go practice, 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 because we get to start rotations.